Hey guys, this is Mrs. Mindy, and I'm going to talk to you a little bit today about magnetic fields. So, how do we know that the Earth has a magnetic field? Well, compasses. We know that there's a magnetic field because of compasses, and compasses have floating or otherwise easily movable magnets that line up with the Earth's magnetic field. And the side that you usually look on to point north is this red end here, in case you haven't seen a compass before. Okay, now here's a weird thing. Look at the Earth. Okay, so if here's the North Pole of the Earth, but the North Pole is a South Pole magnetically. So every magnet is divided into North Pole and South Pole. And we call it that, we call what we call the magnetic North Pole, the Earth's south magnetic pole, um, is because the North Pole of magnetics point to the North Pole, the geographic North Pole. So where does the compass point? It points north. The red part points to the North Pole, unless there are stronger magnets around, which there frequently are, because even though the Earth's magnetic field is really big, it's not really strong. You can easily overpower the Earth's magnetic field with anything sticking to your refrigerator. Okay, so those two ends on a magnet are called the South Pole and the North Pole. South Pole, North Pole, South Pole, North Pole. Now notice there's a direction to these magnetic fields too. See how it goes out of the North Pole and into the South Pole. Whoops. Okay. So you should draw this shape, or basically this shape, or this shape. It's all the same shape, but you should know this shape in your notes. It's the shape of a magnetic field around a magnet. And here there are little bits of iron that are sprinkled, and they've oriented themselves into this shape. And this is a drawing from oldie-timey days of the same thing. Some animals have a magnetic sense that helps them navigate too. So they have a way to feel the magnetic field of the earth. And so like regular pigeons are one of the animals that do that. Like ends of magnets, so like ends means the same type of ends of magnets repel, and unlike ends of magnets attract. So north repels north, south repels south, but north and south attract each other. You can see the magnetic lines of force pulling them together. Okay, so here's that tricky point again. The geographic North Pole is a magnetic South Pole. So the red magnetic North Pole of the compass's magnet points to the Earth's magnetic South Pole because, they're opposites. Okay, North Pole, South Pole, but this is obviously what we call the North Pole, like where Santa Claus lives. That's where the compasses point. Here is a really early compass. The earliest known were from China about 4000 BCE, so about 2500 years ago. If you haven't heard of this BCE, that's before Common Era, because people didn't like BC if they were not Christian, because it referred to Jesus being born. So they say before Common Era. And this spoon-like thing, it's pretty heavy on the one side, and it's on this smooth disc in the middle. And this little handly looking thing, that's the pointer. So it's carved out of a piece of natural magnet because that occurs. There's some rocks are naturally magnetic, and it points north. So it's especially um, useful in cultures like in Islam where they need to know where Mecca is, like what direction to pray in. Oh, yeah, yes, I forgot I did this. So Muslims brought the Chinese compass to Europe. Compasses were used for a lot for finding Mecca, and you can see this is a replica, and it's really small. It's like a little coin, and I think that's really cute. I actually want one of these. There's Mecca. Oh, and there's a video which I cannot show you because this is embedded in another video. Compasses have been used for navigation, going from one place to another, not getting lost, for about 1,000 years. So this is a ship's compass. The Earth's magnetic field makes the northern lights, southern lights too, but the northern lights are closer to us by funneling high energy plasma from the solar wind. Solar wind? What is the solar wind? Okay, so the solar wind is a stream of particles that comes out from the sun all the time. All the time. So it's shooting, the sun is not only, sending light out to us, but it is also sending charged particles out in every direction at once. Okay, it's just a fountain of these particles, not just at the Earth, all over the place. But the Earth's magnetic field protects us from this solar wind. So the magnetic field moves the solar wind particles because they're electrically charged, and charged particles can be controlled by a magnet. So just thinking again, what makes the magnetic field? Okay, so it's not, we don't have a permanent magnet inside the Earth. It's the outer core of the Earth that seems to be making the magnetic field. So remember this from seventh grade, possibly. If not, there are different layers in the Earth. So here's the outer mantle. The outer core is melted iron. It can't be a regular permanent magnet because if you melt a magnet, it is no longer magnetic. It just sort of goes randomly around. Melted iron moving in the outer core appears to be making a giant electromagnet. Okay, because if you have electricity and movement and magnetism are all connected together. So this motion um, of the outer core seems to be generating the electromagnet of the Earth. So why do you care about the Earth's magnetic field? And it's because you like breathing. Without it, the sun would blow away our atmosphere. Those particles would rip away at our atmosphere and just blow it away. It has happened to other planets. Okay, so which layer of the Earth makes the Earth's magnetic field? Do you remember? Did you write it down? It's the outer core. Okay, permanent or regular magnets, the ones that you think of as being a magnet, they don't work if they melt. So in a magnet, there are little mini magnets or domains inside them that get loose when the iron is heated. And they just interact with each other and they turn every which way. So the mini magnets cancel each other out unless they're locked in place. So you can do this by locking them in place while it's molten, putting them in a strong magnetic field, and then it cools down and then they got locked in. But if you don't, you can wreck a regular magnet by heating it or otherwise scrambling up these little domains. Like by dropping a magnet, you can wreck it. Here is an electromagnet. An electromagnet uses the magnetic field that is created from current moving through a conductor, makes a magnetic field. And so we can use this for like picking up heavy metal things and then being able to drop them without sort of physically supporting them, but just the magnet holding them up. So electricity moving through iron or any other conductor can be, makes an electromagnet. And it makes, if you make it into a coil like this, it makes the same pattern of field lines as a permanent magnet. Okay, so this is kind of like the stickiest part here and here, just like on a magnet, the stickiest part is here and here. That's it for electromagnets. I'll see you next time.